Let's begin to understand how to use the C interpreter Picoc and the C compiler GCC. First, with the interpreter. You can get to the interpreter by logging into Vera Virtual, opening a terminal, and entering cint for C interpreter. And what you'll come to is the Picoc prompt. At this prompt, you can enter C instructions, such as int a equals 20. It's an assignment instruction. It creates a named memory cell A and puts the value 20 in that memory cell. There's no response because it's not an expression, doesn't have a value. Here's a function call. It's a library function, printf, and this particular library call has two arguments. The first argument is a formatting string. Everything inside the double quotes is going to appear literally as is shown. A equals all the spaces except for with two exceptions. One, the simple one, /n at the end, is not going to appear literally. It's an escape code, meaning that it isn't printing it literally, but it is going to enter in the string the code for a new line. Because what the interpreter will do, will take this and enter the ASCII codes for each character. It will treat /n as one character and enter the ASCII code for that. %d is different. %d is paired with this variable here. Whatever, this %d won't appear in the string, but the value that's in the variable memory cell A will appear. So what this is going to do is going to print A equals 20, then enter a new line, and that's what happens. The A equals 20 comes from this, and the new line brings the Picoc down here. Okay, let's continue with another version of printf. This function call, for the same function, but it has a different number of arguments, shows that printf can have a variable number of arguments. The first is always a formatting string, and there can be a series of %s, %ds, %x's, %s's. There's a whole set of formatting codes, depending on what the type of the value is on the right that you want to print. Now, this %d matches with 2 times A. A is 20, so this is going to be 40. So this is going to read A equals 40 in hex, sort of misleading here because this is going to be the hexadecimal version of A. Now the hexadecimal version of A means base 16, so there's like 116 in here and 4 left over. So this is going to be 14. Let's see if that's correct. A equals 40 in hex 14, or 14. We don't want to read hex as 14 because that suggests that it's base 10, whereas this is really base 16. Usually you'd put a 0x in front of it. If you want to put the 0x, you have to put that in front of the % over here. Now, these two are library functions. They work underneath by making system calls, because system calls are the only way to access system resources like the monitor, the screen. Okay, so each of these is going to produce something like, well, this second one is going to produce something exactly like this. It's a system call. It's called write and has 3 arguments. And the arguments are all integers, even though this doesn't quite look like an integer, the second argument. The one here specifies where the string that the write produces, the sequences of bytes that it sends should go. 1 indicates the computer screen. The 17 here tells write how many characters, how many bytes to send. Now I've counted here, there's actually 17 bytes here, 17, because this one doesn't count as 2 bytes, it counts as 1 byte. Now, if I only put like 5 in here, it would only do it would only send 1, 2, 3, 4, 5. It would only send the A equals 4 on, and that's all we'd see. We'll explore this kind of thing later, but for now, let's just see that in fact, this system call does exactly the same thing that the printf statement does. So in this course, we're going to be using mainly system calls to understand what's really going on underneath. Okay, here's another version. You can see I've changed this we're only going to send 16 now. So we're not going to send the /n here because there's 16 characters here, and this is the 17th one which you've left off. So if you enter that in Picoc, what you'll get is this, because enters the sequence of characters up through 14, the first 16, but doesn't enter a new line. So when it returns, the prompt Picoc just comes over here. Now this might be a little bit annoying, and sometimes if you write half an instruction, you'll get a prompt that's sort of misplaced. To correct that, just enter the termination of a command and press enter, and you will get back to the correctly placed Picoc prompt. If you want to exit Picoc, you enter Control D. Because what's going on here is that this sequence of bytes at a equals 20, printf, this whole thing here, the whole printf line here, the whole right line, the whole right here, is a sequence of bytes that's a file. It's the file coming from the keyboard. So it's standard input. That's what that file is called. And there's a second file, a equals 20, a equals 40 in hex with new lines, a equals 40 hex with new line, a equals 40 in hex 14 with no new line. And that's a second file that's going to standard output, which is the screen. And this code here, Control D, signals end of file. And what will happen is it will terminate the Picoc interpreter. Now let's go on and look at GCC. It is a very big compiler. In fact, GCC stands for the GNU Compiler Collection. It's actually includes in it the option to compile many different languages. Let's enter our first C program, or a first C program, into a text editor. So you can see from this that C has multi-line comments, just like Java, and it's the first line of the program here. Starts with what's called a main function, and you have a return type int, and you have no arguments. That's what the void means. And the first instruction we're going to execute is a equals 20. Then we're going to use the same printf line that we used in the interpreter. It's going to print a equals 20. Then we return 0, indicating success. There's the closing curly brace. So a lot of this elementary syntax here should appear familiar from Java. It's a list of instructions inside a function definition. It looks like a method definition, except it's not inside a class or object. C doesn't have classes or objects. Okay, at the bash shell prompt, once you've entered this into a text editor and saved it into a directory, which is where this directory is, as long as you've arranged that. We talk about more of this in other contexts. At the bash shell prompt terminal, this is the command you enter to compile that program. You type GCC, the name of the program, the name of the file you want to compile, cshell.c. We always put .c at the end to indicate that it's a C source code file. -o means this is an option. That's what the dash indicates. The O specifies that we're indicating the output file, C shell. If you don't put this, it goes to a default output called a.out. Okay? Now, we should get, if everything's well, we should get no response because silence is golden in this context, but we don't. We get a warning. Now, a warning is not an error, so it actually did compile the program, but what we've left off, if you actually look at the warning here, is we've left off the header for this function. The header needs to be up here in order for the compiler to know what the return type is, to be able to check that the program is working well, okay? But since it's only a warning, we can go on and still run the program. And here's how you run the program. You put ./C shell, the name of the executable, the name of the binary image that was created by the compiler up here. The dot means the current directory, and the slash means in. So this is saying, this is telling the shell, the terminal, to look in the current directory for the program with this name and execute it. And what you see is it will print a equals 20, because it will carry out these instructions, then return, and that's all there is for this video.